This exercise 3.5, question 13, okay? The numbers 1.8, 2.6, 4.8, 7.2 have a mean mu at standard deviation sigma. Verify that u minus sigma equals 2. So, what you do first and foremost is go to your calculator, go into stat mode, one variable, write in 1.8, 2.6, 4.8, 7.2. 7.2. Okay, now that you have that done, you press the AC button, then you go shift, second function, stats, variable. The mean, which is x bar, is mu, right? That's your mean. My mean is the 4.1. Okay, so mean is 4.1. Mean equals 4.1. And now that we know the mean is 4.1, what we're going to do next is going to go, work away. Going to find out what the standard deviation is. Standard deviation is the third one. Press it there, and you get 2.1. And also what it says is verify that the mean minus the standard deviation is 2. So basically 4.1 minus 2.1 equals 2, which it does. Hence the question is done. Okay, just got to use your calculator, find the two values, take one away from the other. Okay. Next question we had was I was asked to was question 17. Now this one appears to be I got the question now at last. Alright. Here's what it is. Okay. In each case, right, construct a set of data with 6 elements where mu equals 9. I want the average to be 9. What's 6 times 9? 54. I'm going to write down 6 numbers, and all of them, when you add them all together, will add up to 54. So what I can do here is I can go, I'll just do 2. I'll keep it below the average, okay, so it makes my job easy. 5, 7, what's that now? I'm on 6, 11, I'm on 18, okay? 18 leaves, take away 18 from that, that leaves me 36 to play around with. So I'll do 10 and 26.
Just do 6 9s.
You could do 6 9s, but I'm going to save that for the next one. Okay, this is an example of 6 numbers that has a mean of 9. Question 2 is write down 6 numbers, any 6 numbers you want that have no standard deviation. They don't have to add up to. The mean doesn't have to be 9, so I can just do this: 3, 3, 3, 3, 3, 3. Okay, basically for this question here, there's no standard deviation because they're all the same. The third question is, which one has a mean of 9 and a standard deviation of 0? That is going to be 9 all the way across. 9, 9, 9, 9, 9, 9. Okay? Away the field, please. Okay, so that's it there. Okay, that's number 17 done. The next one, number 18, is the ages and incomes in thousands of the 10 employees at a city department store are recorded in the table below. Compute the standard deviation of age and incomes for these employees. Assuming all employees remain in the company for 5 years, that each income is multiplied by 1.5 over that period. What will the standard deviation of the ages and incomes be 5 years from now? Okay, now this is a reasonably tough question. Now I have a way of shortening this down for us, okay? Now the way I can shorten this down is the most you just do age on its own, and then you did income on its own. Now there's another way of doing this that will save you a bit of time, right? But I haven't done it yet. I would have expected you to do them individually last night. Okay, but here's another way of doing it. So you got the mode set up again. Now see a plus bx. That means you have 2 variables. I do have 2 variables, don't I? I have age and income. Okay. So I'm going to go for 2 variables. Now I'm just going to type in the age first. Age is x. Okay, so please make a note. Age is x and income is y. So I'm just going to write them all in. 28, 30, 40, 55, 29, 45, 42. What comes after 42?
55.
And after 55? 37. After 37?
39.
39. Okay, perfect. Okay, that it? 10. Now, what I'm going to do next is I'm going to put in all the other values underneath it. So what's that? 24, yeah? 26. 30. After 30?
48.
48.
35.
35.
38.
38.
32.
32.
53.
53.
40.
40.
44.
44. Stop there, right? I input it in once, okay? Now, it's the exact same trick as last time, except this time, because I have two sets of data, there's going to be more options. There's going to be X bar, Y bar, standard deviation of X, standard deviation of Y. So you can get it done in one go. Now, do you see the extra options? It's exactly like last time. So the average of the age is 40. Who got 40 for the average of the age? Okay, so that is 40 for the average of the age. Just keep working with this for a minute. That's X bar. This is X. This is Y. Okay, next thing I have to do is find the standard deviation of X. Once again, it's all just in the calculator. Okay, shift, stat, variable, tree. The standard deviation is 9.24. Everybody get that? Okay, next one is Y bar and delta Y. So what we're going to get here is shift, stat. Just pitch out these two first, okay? 5 average of Y's is 37. Everybody happy with 37? And finally, that last one is shift, stat, number 4, question part 5, and that, oops, I already did that, sorry. Shift, stat, 4 is number 6 for the standard deviation of Y, 8.97. Let's round off to 1. 8.97, okay. I have a question there, just give me a second. Okay, what we're going to do next is add on age, okay. The age is going to be 5 years for each one, so that's going to be 33, 35, 45, 60, 34, 50, 47, 60, 42, and 44. Can somebody be so kind as to multiply 24 by 1.5? 36, I think. Actually, I can do this. 39, 45, 72, thank you. 52.5? 57? 48? 69.5? 79.5. 60? And finally 66. Okay, grand. Now, will you guys keep those numbers there, because my calculator is about to cover them up, okay? I can't unfortunately make this thing smaller. So we're going to go again. Okay, modes, stats, 2 variables, and we're going to go again, okay? 33, 35, 45, 60, 34, 50, 47, 60. What comes after 60?
42.
After 42?
44.
Yeah, after that? Oh, that's it. Okay. Go back up to the top. And let's go to the Y values. 36, 39, 45, 72, 52.5, 57. Yeah. 48. 79.5. What else?
60.
60.
56.
Sorry?
16, 66.
66. Yeah. Okay, perfect. Alright guys, let's see what's going on. Okay. Shift, stat, for standard deviations only, wasn't it? Okay. Okay. Number 3, standard deviation is 9.24 for the age. The age is exactly the same. Now that's interesting, okay? You added on 5 years to everybody, but the spread is still the same. Now I'm going to explain that to you in a second, okay? I'm going to show you a way how to explain that. Okay, shh, lads. Okay, now delta y. Let's see what happens here. Shift stats variable. Number. Oh, sorry. Yeah. Sorry, guys. Shift stat for number 6. 13.44. Now that one has changed, okay? 13.45, excuse me. Now, just out of interest, okay? The way I think is this. I'm going to divide the old standard deviation by the new standard deviation and see what happens there. Oh, sorry, you can just do answer. Yeah. Answer divided by, what's it, the old standard deviation? 8.97, isn't it? 1.5. Do you notice that? If you multiply everything by 1.5, the standard deviation
Increases by 1.
increases by 1.5. Okay.
But it's not times.
So,
Wait, it's times 1.5 or it's like plus 1.5? Most
1.5, as in it's if I multiply every figure by 1.5, I'm making the standard deviation bigger. Okay. Now I'm going to explain why.
So you don't even have to do that whole 1.5 times thing.
Yeah. Okay. Now we're going to about both sets. Okay. Shh. Assuming all employees remain the same with the company over 5 years and that each income is multiplied by 1.5 over that period, what will be the standard deviation of ages and incomes 5 years from now? Now the standard deviation of ages remains the same because we're adding. Now the deal is what adding is, if we have a distribution, okay, which has a standard deviation, if we move this distribution to the left, that's the same as reducing age. If we increase age, everybody's age gets increased by the same amounts. This means that the distribution doesn't change, therefore the standard deviation remains the same. Now, however, when we look at incomes and we're multiplying the incomes by 1.5, okay? Now the problem is with the incomes is they're not increasing by the same amount. Okay, they're all increasing by different amounts. So this one here increased by 12. This one here increased by 13. This one increased by, was it 15? Yeah? Yeah. This one increased by, what did it increase by? 24. You can see that they're getting further and further separated. This is why your standard deviation was increased by a magnitude of 1.5. Long story short, when you multiply all your figures by a number, any number, the standard deviation gets increased by the same number. If you add the same number to each data in your set, the standard deviation is unaffected. However, the mean will go up. That's it in a nutshell, okay?